Okay, this is for case number 3, which is for population standard deviation unknown and n less than 30, small sample size. Okay, for case number 3, the difference is in terms of the test statistic that we're going to use. Okay, for case 1 and case 2, we use Z, but for case number 3, we're going to use T. Why? Because n here is small, which is less than 30. So step number 1, again, state the null and alternative hypothesis. It can be left tail, right tail, or two tail. And for the test statistic, we have T equals to x bar minus mu divided by s over square root n. Okay, and then the critical value also, we follow T. So for left tail, we have negative T alpha n minus 1. For right tail, T alpha n minus 1. And for the two tail, plus minus T alpha over 2n minus 1. And then the decision rules. Okay, for left tail, we reject H0 if T less than negative T alpha n minus 1. For right tail, reject H0 if T greater than T alpha n minus 1. And for the two tail, we have two conditions. Reject H0 if T less than negative T alpha over 2n minus 1 or T greater than T alpha over 2n minus 1. Okay, since this the two tail, remember to divide alpha by 2. Okay, we also can use p-value approach. Okay, same like case 1 and case 2. And then step number 5, make a decision and conclusion. Okay, let's take a look into example 7. The specification for the production of certain alloy call for 23.2% copper. A sample of 10 analysis of the product show a mean copper content of 23.5% and standard deviation of 0.24%. Can we conclude at one significance that the mean copper content is higher than the required specification? Assume the copper content is normally distributed. Okay, based on this example, the information that we have is sample size here is 10, which is less than 30, and we does not know the population variance or population standard deviation. So we have value x bar equals to 23.5, sample standard deviation 0.24, n equals to 10, and alpha here is equals to 1% or 0.01. Okay, so we want to test. Okay, we want to test whether the mean copper content is higher than the required specification. So this will be our alternative hypothesis. So for null hypothesis, mu equals to 23.2, H1 mu greater than 23.2 because the keyword here is higher. Okay, and then calculate the test statistic. We're going to use T, so we get T equals to 3.95. Okay, so don't forget to write here, this one is right T. Okay, because greater. Okay, and then find the critical value. So we have T alpha n minus 1, T alpha 0.01, n minus 1 equals to 9. So we get 2.821. Okay, now we want to write the decision rule. Okay, so since this one is right tail, so we're gonna look at the right side. So our critical value is 2.821. Okay, so we will reject H0 if the test statistic is greater than 2.81, which is if the test statistic is false in the rejection region. Okay, region yang saya shadedkan ni lah. Okay, so now, so that's why we come up with the decision rule. Step number 4, reject H0 if test statistic greater than 2.821. Okay, look at our T. T kita is 3.95, which is greater than 2.821, false in the rejection region. So we can reject the null hypothesis. Okay, since test statistic 3.95 is greater than 2.821, we reject null hypothesis. Therefore, the test is significant. So the conclusion here, there is a significant evidence to indicate that the mean copper content is higher than 23.2%. Okay, now we want to try by using p-value approach for the example 7. Okay, but for this example, we should look into the T table, okay, which is table number 7. Okay, how to look into this table? Okay. Okay, we should look into degree of freedom 9. Okay, and we get our T equals to 3.95. Okay, so what is the p-value for this test statistic value? Okay, kalau kita tengok dekat dalam table ni, tak ada exact value 3.95, betul tak? Tapi apa yang boleh kita buat interpolation. So kita boleh nampak 3.95 tu adalah berada di antara 3.25 dan 4.297 yang saya bulat merah ni ya. Okay, so our p-value nanti akan berada di antara 0.005 dan 0.001. So apa yang kita boleh buat? Kita buat interpolation. Okay, saya dah ajar itu kan dekat chapter sampling dulu. Okay, so after we do the interpolation, we get the p-value equals to approximately 0.002. Okay, now kita dah tahu p-value. Decision rule kita adalah reject H0 if p-value less than or equals to alpha. So since we get p-value 0.002, which is less than 0.01, so we reject the null hypothesis. Therefore, the test is significant. So the conclusion is there is significant evidence to indicates that the mean copper content is higher than 23.2%. Okay, again, either using classical approach or p-value approach, your decision should be the same. Okay, tak boleh tak sama lah, mesti sama. Okay.